In previous lessons, you've written equations of parabolas that open up or down, but in lesson 9.2, we're going to write equations of parabolas that open left or right. And a parabola is a set of all points that are equidistant to a point, which is called a focus, and a line, and we're going to call that the directrix. So even in a parabola that opens up or down, our focus is always going to be inside our parabola, and our directrix is going to be below our parabola. And I also said that they are equidistant. So if I look at my focus, and I draw a line from the focus to the parabola, that distance is going to be the same as from the parabola down to the directrix. And also notice when it hits the directrix, it should hit in its perpendicular, so 90 degrees. And our eyes play tricks on us. It doesn't look like these diagonal lines are perhaps the same distance, but if you take out a measuring tool and pause the video, you'll see that they truly are. Okay, so I mentioned that the focus is on the inside, the directrix is below. That was one key point. I mentioned that from the focus to the parabola and the parabola to the directrix, those distances will be congruent. When it hits the directrix, we know that it creates 90-degree angles. And the last thing I'd like to point out is that the focus and the vertex are on our axis or line of symmetry. Now we'll take a look at our new equations. Our new standard form for our parabola that opens up or down is going to be x squared equals 4py. You need to pause the video and write that down. The p value is going to tell us where the directrix and the focus are. Our focus is some point like O0 or 0p. I called it 0,3, and our directrix is going to be the opposite. So it would be y equals negative p. And in this instance, I labeled it -3. And then we would have our parabola drawn in here. Something like that. Okay, so if we know one, we can find the other since one is the opposite of the other. Our equation for a parabola that opens left or right is going to be y squared equals 4px. So again, pause the video and write this formula down. Y squared equals 4px, and that is for a parabola that opens left or right. So in this instance, our directrix is x equals -p. That gives me this vertical line, and I chose an arbitrary point of x equals -4. And then our focus is going to be the opposite. So I have a +4. So we think of that as p, 0. Also, you should remember that the focus and the vertex are on our line of symmetry. So our graph might look something like this. So our focus is on the inside of the parabola, and our parabola is above the directrix. All right, let's try this one. So we're going to determine if this opens up or down, left or right. We notice that we have y squared. And if we go back to what we learned on the previous slide, if it says y squared equals 4px, then it's going to open left or right. And that makes sense because if you think back to Algebra 1, when we had y equals x squared plus 2x minus 5, for instance, when we had the x squared, it always opened up or down depending on if it was negative or positive. So the y squared is left or right. In order to get this purple equation to look like the orange equation, we're going to have to isolate the y squared. So we're going to multiply both sides by -8 or -8/1. So we end up with -8x equals y squared. So over in the orange equation on the left, we have 4px. So we're missing a term. So we need to figure out how to get -8 to include that 4. So I could say -8 is the same as 4 times -2x equals y squared. And if I wanted to, I could write it this way. So now I have y squared equals 4 times -2x. Our p-value is -2, so that ordered pair is going to be -2, 0. So I'm going to go over to the graph and plot that. Now our directrix is the opposite of that p-value, so it's going to be x equals 2, and we know that x equals 2 is a vertical line that goes through 2. And remember I said that our focus is going to be on the inside of our parabola, and the directrix is going to be below. So now we have an idea how we can get this to be graphed. So our graph would look something like this. We can see that our focus to the parabola is equidistant from the parabola to our directrix. If we wanted to be precise, we could make a table of values, sub in values for x, and solve for y. But we're going to look at 2 more examples. In this example, it's asking us to write the standard form of the equation given that the focus is 0, -6. So we know we're going to go down to 0, -6. The vertex is the origin 0, 0. And our directrix we know is going to be y equals 6, because we know that it's the opposite of our negative value. Because the focus is on the y-axis, we know it'll open up or down, so the equation we're going to use is the x squared equals 4py. We know p equals -6. So now we have x squared equals 4 times -6y. And we could simplify that to x squared equals -24y. And that's our standard form of the equation for this particular graph. In this equation, they didn't give us the focus, they gave us the directrix, and it's x equals 3. So we know that x equals 3 is a vertical line that goes through 3. So that means our focus is going to be -3, 0. It says it goes through the origin. And now we're going to start to write our equation. We know we're going to use the form y squared equals 4px because it says that our directrix was x equals 3. So we know it's going to be a left or right opening. Our equation is going to be then y squared equals 4. Our p-value is -3x, and then we simply reduce that to y squared equals -12x. So our graph might look something like this. And again, we could make a table of values and plug in x values to figure out our y's and get an exact graph.